So we've done some expansion, and now we're just going to do the opposite. So skills we're familiar with, but we're applying them. I mean, we're reasonably familiar with polynomials, but looking specifically here at exponentials, which might be a bit of a challenge. So let's see how we go. So with factorisation, what we're doing is we're looking for factors that are common to both terms and then pulling that out the front. That's the opposite of expansion. So 49 to the power of x, what we should be recognising here, we've got 7 to the x here. We can write this one as 7 to the power of 2x. Okay? And then that's plus 7 to the power of x. Now 7 to the power of 2x, all right, what we can recognise is that's 7 to the power of x times 7 to the power of x. Okay? But if you recognise these have the same base, and therefore we can add the powers together, we could simplify it to be that. And so we're doing the opposite of an index law. We're not collecting them, we're splitting it up into two terms. Okay, so that splits into 7 to the x times 7 to the x. And then over here we have plus 7 to the power of x. Okay, and so then we've got two terms. This is our first term. It's equal to 49 to the x. We haven't changed the value of it, we've just changed the way it looks. Okay? And then over here we've got 7 to the x. And so we're saying, what is common between this term and this term? 7 to the x is in this term, and it's in this term. So we're going to pull that out the front. Now if we pull 7 to the x out the front, what's going to be left over? Well, we're only pulling one of them out, so we're going to have 7 to the x hanging out there, and then over here it's going to be 1. Okay? And the way you know you've done it right is if you expand this, does it equal what you have up here? Okay, so let's talk about that quickly. We split this into two 7 to the power of x's, and then we recognised it's 7 to the x is common to both of them, so we can pull that out front. Okay, so let's have a look at this one. 3 to the n plus 2 plus 3 to the n. So again, we are going to split this one. We have 3 to the n plus 2. We're going to write that as 3 to the n times 3 to the power of 2. Okay, same base, and if we add the powers together, that's the term that it would simplify to become 3 to the power of n. And then over here we have this 3 to the n hanging out. Okay, so I'm going to show you guys a little trick here that can help you if you're sort of struggling to see what's a common term between these two. All right, we're going to apply it over here a bit as well. We can do something like let a equal 3 to the power of n. Let a equal 3 to the power of n. Okay, so if we do that, then what we've got, let's substitute a in. We're going to have a times 3 squared, and then over here plus a. Alright, and so what that gives us is we've got 9a plus a. Okay, 3 squared is 9. 9a plus a. That gives us 10 lots of a. And then you say, well, what is a? What do we define it as? A is 3 to the power of n. So 10 times 3 to the power of n. Okay, so that's one path that we can follow. We can make that recognition. The alternative way is up here. 3 to the n is common. We can pull that out the front. Okay, if we pull 3 to the n out the front, let's follow that path here. Let's split it up a bit. I think that's big enough. We have 3 to the n plus 1. We pull 3 to the n out. What are we left with? 3 squared plus 1. Okay, it's common here and here. We pull it out the front. The 3 squared remains, and 1 then. If you distribute this, that's what it's going to become. And then 3 squared is 9. Yeah, no worries. Have a nice day. 3 squared is 9, plus 1 is 10. So we've got 3 to the n times 10. It's exactly the same as what we've expressed down here. Okay, let's move on to C. Now this kind of one's going to be popping up a fair bit. This is difference of two squares. Now, there's no real shortcut here. I'm going to show you the difference of two squares expansion. Okay, if you expand this is what we're going to get. And so whenever we recognise a squared take b squared, we can factorise it to be like that. And there's no shortcut in between those two, Emily? Okay? So 4 to the x, we can write as 2 to the power of 2x. All right, 4 is 2 squared. And 9 we can write as 3 squared. Now I've said here, like 4 is 2 to the power of 2, and we're going to multiply them. The order doesn't matter, so we can write that as 2 to the x squared. Okay? You can see that they're going to be the same. Okay, I'm just stretching it out a bit here, so that we can see we've got a squared take b squared. 2 to the x squared take 3 squared. And so then that we're recognising this form, and we're going straight from there to here. We've got 2 to the x take 3 times 2 to the x plus 3. Okay? If you expand that and simplify it, this is what it will become. Okay. Last one. We've got 9 to the x plus 4 times 3 to the x plus 4. Now this is as tricky as they get, and we're definitely going to use that hack that we learned over here. First, I'm looking here, we've got 3 to the x, and then I'm saying that's 9 to the x. So we're going to want to express it in the same form. We want to express it as 3 to the x squared. Okay, we'll get pretty good at making that recognition. Now looking at that, that's going to be very difficult to factorise if you were just looking at that. But let's use our little hack again. We'll go let a equal 3 to the x. Okay, so if a is 3 to the x, then what we've got a squared plus 4a plus 4. And that, looking at that, that is something that's much easier for us to factorise. It's not heaps easy, but it's something that's much easier for us to factorise. So this is cross method. We're going 2 things that multiply together to give us a squared is a and a. 2 numbers that multiply together to give us positive 4. And when we add them together, we get positive 4. So you can try a number of procedures out, but this is going to be our solution. We can see a times 2 and a times 2 is 2a plus 2a gives you 4a. So this is our solution. A plus 2 times a plus 2. That's a plus 2 squared. And what is a? A is 3 to the x. So it's 3 to the power of x plus 2 squared. If you perform this expansion, that is what you're going to get. Alright, so I'll just chat about that one quickly again. 9 to the x we recognise as 3 to the x squared. We define a, now that's a quadratic, and then we factorise that quadratic and substitute a back in. Okay, so if you look at what we're doing here in semester 2, like this was sort of recapped all in semester 1. So we're sort of using that assumed knowledge and applying it again. It's all related. Okay, and then the trick over here with these two is when you have 7 to the 2x or 3 to the n plus 2, is you're doing the reverse of index laws, aren't you? You're splitting it into what it was before it got simplified. Okay, so 3 to the n plus 2 is 3 to the n times 3 squared. And so you can see if you collect them using index laws, that's what it simplifies to. So this will be reasonably challenging, but let's give it a bit of a go. 12F.2. All right, yeah, see you, Sophie. Have a nice evening. Thank you.